Okay, now we move on to three slightly meatier questions involving parallel lines and perpendicular lines, but also using some of the skills that we learned in the last couple of lessons. So here we're given 2 points, 0, 7 and 3, 5. We're asked to find the equation of the line parallel to AB, that's the line between these 2 points, but passing through the point 2, 7. So we need to know something about the equation of the line AB, and the key thing we need to know about parallel is the gradient of that. So first thing we're going to do is we're going to label up our points x1, y1, x2, y2, and we're going to use our gradient formula, m equals y minus y1 over x2 minus x1. We're going to know our numbers, so we've got 5 take away 7 over 3 take away 0. That gives us minus 2 over 3, or more simply, we could write that as minus 2/3. Now, we could now do the parallel gradient. What do we know about gradients? Well, we know that if 2 lines are parallel, then their gradients are the same. So the parallel gradient is also minus 2/3. Okay, there's no real, well, there is actually a fancy symbol for it, but we don't usually use it. Just knowing our parallel gradient is minus 2/3. Now we've got our 2 options to work out the equation of this line. Now we don't want the equation of AB. We've got the only bit of information we need to know about is gradient. We don't need to find anything else. What we now need to work with is this parallel gradient and the point that this line needs to go through. So methods, so we've got y equals mx plus c. Putting our numbers in, and y equals minus 2/3 x plus c. Putting our y as 7 is minus 2/3 2 plus c. That's 7 equals minus 4/3 plus c. Adding our 4/3 to this side over here, 7 is 21 over 3. So altogether we have 25 over 3. C. Remember, finish off by writing that line equation. Don't just leave it like this. So our line equation is y equals, the gradient is minus 2/3. And 25 over 3. So that's this, we've worked out the y-intercept of this line we're interested in as well. Now we've got our second method, which is y minus b equals m lots of x minus a. I'm actually going to show you a nice little trick with this today. Putting our numbers in, y minus 7 equals minus 2/3 x minus 2. Neat little trick, if you've got a fraction here, you can multiply everything through by 3. So we get 3y minus 21 equals minus of x minus 2. Expand our bracket, we get minus 2x plus 4. This side here stays the same. And then we want to add 21 to the side, so we get 3y equals minus 2x plus 25. These two things are exactly the same. If I divided both sides of this by 3, we'll get that equation there. So we've actually got the same answer. Just want you to always have in mind those two methods so that you can choose the one that you're most comfortable using. We're going to look at a second question now. And the second question is almost identical. We've got 2 points listed in a line with a line equation relating to AB and passing through a point, but this time we're interested in a line equation which is perpendicular. We're going to start in exactly the same way though. We're going to do our gradient of the line AB. In fact, I might even just put MAB there just to remind myself that's what I'm looking at the gradient of at the moment, is the gradient of AB. We've got 6 minus 4 and minus 3 minus 2. Label up your points if that's still something you find you need to do. No problem there. We get 2 over minus 5, or more commonly we might write that as minus 2 over 5. Now the key difference here is we're looking for the perpendicular gradient. Perpendicular. This is minus, so our perpendicular gradient will be positive. This is 2 over 5, the reciprocal. We'll flip it upside down. So our perpendicular gradient, our gradient of this perpendicular line, is 5 over 2. Again, we're going to use our two different methods. So firstly, start equals mx plus c. We get y equals 5 over 2x plus c. We're putting in the point 10, 8. So we get 8 equals 5 over 2 times 10 plus 5 times 10 is 50, divided by 2 is 25. So we get 8 equals 20 plus c. So c equals minus 17. Final thing, write that equation. So y equals 5 over 2x minus 17. Using our second method, just so you've got it, 1 minus b equals mx minus a. As I say, you don't need to do both. I'm just showing you whichever one you're comfortable with, you can use. So get y minus 8 equals 5 over 2x minus 10. Multiplying through by that 2, so using that fraction trick again, we get 2y minus 16. So we need to multiply both by 2. 5 lots of x minus 10. That gives us 2y minus 16 equals, and expanding the bracket gives us 5x minus 50. Adding the 16 to both sides, we get 2y equals 5x minus 50. Add 16 is minus 34. And again, if we divide both sides through by that 2, we get exactly that formula there. Okay, so two skills. If I give you a line, some line AB, then I can find a line that's parallel or perpendicular to it and passing through a particular point. And you'll see most of the questions are like that. There's one other style of question I want you to be able to tackle, and it is the following. And this actually is a question we answered just yesterday, but we answered it in a very different way. We answered it by finding lengths. Today we're going to do something hopefully a little smarter. So, we did yesterday, it's always helpful to sketch our triangles. So we've got 0, 6, we've got minus 6, 2, and we've got 2, minus 10. The reason I'm doing this is I want to get an idea of where I think my right angle is going to be. My prediction is that this is the right angle, so that's the one I'm interested in. So if I can find the gradient of the line AB and the gradient of the line BC, I can check are they perpendicular to each other. If they are, it's a right angle triangle. So this is a little strategy we're going to use, and we're going to work it out with these coordinates to see whether we've got a right angle triangle or not. So my strategy was MAB, and we'll find that. So that's y2 minus y1 over x2 minus m. That's going to be my y2, so we're going to do 2 take away 6 over minus 6 take away 0. That's going to give me minus 4 over minus 6. Minus 4 over minus 6. Minus divided by minus is positive. So we get 4 over 6, or handily we'll simplify that to 2 over 3. Now we also want to know about this one and check whether this gradient and this gradient are actually perpendicular to each other. So the next one we're interested in is BC. Just to mention as well as we go, it's always handy to check, does this seem like a sensible answer? Well, that is a positive gradient that we've got between A and B. It's going up from left to right. So that's a big tick. It's also not a massively steep gradient, so yeah, that seems sensible. y2 minus y1 over x2 minus x1 equals, and now we're putting in our numbers. I've just tried to leave them at the very top here. We've got minus 10 take away 2 over 2 take away minus 6. Now what was that minus? So that gives me minus 12 minus the same as plus over 8. Simplifying that down, move the minus to the front. 12 over 8, both divide by 4. So that's going to leave me with 3 over 2. So we have 2 over 3 and minus 3 over 3. So yeah, we're happy those are perpendicular, but there's a little statement we want to write. So we want to write angle ABC is a right angle Now, how do we know? So that's angle ABC, which we hope to be a right angle, is a right angle. How do we know it's a right angle? As MAB times MBC. So we're going to use that second way of writing our gradient to kind of confirm this. Well, that's 2/3 times minus 3 over 2. And those two multiplied together give us -1. And that's a massive tick. So line AB and line BC are perpendicular. So this is just kind of formalizing it, making it really obvious, and actually writing this statement about gradients multiplying to give -1 is the nicest way to write and answer a question, prove that or show that something is right angles are perpendicular. This is the way to kind of show it and confirm it. So working from that, hopefully you can now have a go at the more tricky ones and you can work your way through those. Hope that all goes well. Please feel free to email or put a message on the group if you get stuck, and have a go at that little check-in quiz at the end to see whether you've grasped all of these key ideas.